Welcome everyone to this IAQM webinar, Air Quality in the Rail Sector. Today we are delighted to be joined by three speakers: James Wright, Lead Air Quality Specialist at RSSB, Philbert, Air Quality Specialist at RSSB, and Azhar, a Chartered Engineer and Environment Specialist working for Network Rail. Today they will be discussing how RSSB and Network Rail are leading the rail industry's efforts to improve air quality. As always, there will be a chance for questions at the end of the presentation, so please do submit these in the Q&A option at the bottom of your screen at any point during the presentation. And if they're directed to a particular person, please do make that clear in your question. I will then ask these on your behalf later on. Thank you very much for logging in, and thank you to our speakers. I will now hand over to James. Thank you, James.
Thank you, yes. So my name is James Wright, and I'm the Air Quality Lead at RSSB. And today I'm just going to give you an introduction to RSSB as an organisation. I'll talk about the issue of air quality and why that's becoming increasingly important in the rail sector. And I'll just give a high-level overview of the work we're doing before handing over to Philbert, who will take you through some of our projects in a bit more detail. So yeah, that's the basic structure for the first part of the presentation. So as an introduction to RSSB, we are the Rail Safety Standards Board, and RSSB was formed around 20 years ago when the industry realised they needed a standalone safety organisation in the years after privatisation, where there wasn't really a sort of central body looking at safety across the rail sector. We are a member-funded organisation, so in order to operate services on the GB rail network, you need to be a member of RSSB, and we manage the standards catalogue on behalf of the GB rail sector, and also input into developing new domestic and international standards for rail. DFT actually fund our R&D work. So we manage a large program of R&D work for the rail sector, covering a wide range of different areas. And RSSB also manage the British Rail Research back catalogue. And as well as that, RSSB is the Centre of Excellence for Sustainability in the rail sector. So we cover a wide range of different areas, but we mainly focus on key areas such as decarbonisation, social sustainability, and air quality. So why is air quality a priority in rail? So as I'm sure you all know, air quality is forecast to improve quite significantly in the next few years in the road sector through schemes such as clean air zones, low emission zones, and an increasing uptake of electric vehicles. Rail is currently estimated to contribute to about 2% of total UK NOx and about 1% of UK particulate matter. But we recognise that rail's contribution could be and is likely to be much more significant at a local level. The rail sector is being proactive to try and understand its impact and make improvements where necessary. So in terms of how rail air quality compares to road, what I've plotted here, I've plotted yearly average NO2 for the worst 5 roadside locations outside of London. This is actually based on 2018 data. So the blue bars are the worst 5 roadside locations outside of London in 2018. The red bars are the worst 5 roadside locations inside London. And then I've plotted published air quality studies from the GB rail sector. So we have RSSB did a study looking at Edinburgh Waverley, London King's Cross, and there was also a University of Birmingham study looking at New Street, although it's important to note that improvements have been made since then. So, but as you can see in Edinburgh Waverley and London King's Cross, the air quality is on a par with the worst roadside locations in the UK. And in Edinburgh itself, actually, the NO2 levels were something like 30 to 40% higher than directly outside the station. In June of last year, RSSB launched the Air Quality Strategic Framework. So this document really brings the rail sector together, because one thing to note about rail in the UK is it's a highly fragmented industry with different organisations who own the trains, run the trains, and manage the infrastructure, as well as various other organisations such as RSSB, looking at safety aspects and other elements of the industry. So really, the main achievement of the framework is to bring the industry together and set the future path moving forward. The framework contains a number of recommendations for the industry, which are relatively high level, but we do plan to update this at the end of the year and will be more defined in terms of targets for the industry moving forward. So the intention is this framework is an iterative process, and over the next few years, we'll increasingly sort of tighten the requirements within the framework and set a more defined path as we move forward. And in terms of our research projects, Philbert will take you through a few of those in more detail next, but we are researching a number of different areas. So we've themed our research by modelling, monitoring and mitigation. Within the modelling theme, we had a couple of projects looking at mapping of air quality and also improving our emissions factors, which is giving us much better information in terms of where and why we might have air quality hotspots across the network. We have a number of monitoring projects. So we've been looking at how to measure emissions from rolling stock. We'll be looking at the air quality impact of depots. We've been doing some personal monitoring studies. So that's more of an occupational health focused study. And we have a stations monitoring program, which will be a widespread network where we will be looking to establish a baseline of air quality in around 100 stations, and that will kick off in around the middle of this year. And then moving forward, we've developed a number of other projects that are more focused on mitigation. So we are just concluding a project looking at rail standards and how they impact our air quality efforts. We are developing some targets as well. So by the middle of this year, we should have a good understanding at a high level of what exposure looks like in the rail sector, and in terms of what we're aiming for as targets moving forward. We have a project that will focus on performance requirements and testing protocols for emissions mitigation. So this will tell us what we need from mitigation technology. So the intention is we set sort of minimum performance thresholds for retrofit devices, and we have testing protocols. The intention is that we don't want to set the bar too high to discourage people coming into the sector, but we just really need to make sure we get the emissions reductions that we need in key locations. And we have another project looking at how we can incentivize the uptake of low emission technologies. So this will give us within that project, we'll develop a better understanding of rail's external air quality costs, and then we'll come up with some options as to how we can incentivize emissions reductions. And I'll just hand over now to Philbert, who will take you through a few of the projects in more detail.
Thank you, James. Hi, everyone. I'm Philbert Chan. And as James mentioned, I will talk through 3 selected examples, because as you can see, we've got a range of projects happening right now. And the 3 examples that we've chosen to present are the T1186, which looks at the rail emissions and the mapping project. And then I'll have a quick presentation for the targets project and also the stations monitoring project. So the T1186 project is a GIS-based project. So as you're aware, the NEI are based on grid squares, and you've got predicted emissions per grid squares. But the project that we're looking at is to look at mapping the emissions actually along the rail track, and look at the specific rail tracks rather than the grid squares. And they will be based on some new emission factors, because the NEI factors used previously were very outdated, and some of the information actually we couldn't quite verify where they're coming from, and they will be used based on new rail activities data as well. The new emission factors are derived from one of our previous research projects, which is T1187. And from that project, we found that the previous data from the NEI were actually overestimating quite a bit. And as James mentioned, the previous prediction was that the rail contributed to around 4% of the national emissions, but with the new data, we estimated that it's only about 2%. And with regards to the activity data, apart from the existing data that we've got some new data from Network Rail, and also some new TAPS data, which is called the Track Access Building System. So we from that set of powerful data, we have quite a good breakdown of activities across the rail network. And then as part of the project, we also did a bit of analysis looking at the emissions at air quality measuring areas and also clean air zones. So trying to estimate how much emissions there are from trains in terms of absolute emissions and also the percentage contribution versus the total emissions from all the different sources. And next slide, please, James. So this is how the tool looks like. So it's based on ArcGIS Online. And the figures on the top left hand is that it shows basically how the rail track looks like across the entire nation. So as you can see, there's quite a comprehensive coverage for all the rail tracks. The figures on the top right shows the total NOx emissions along these tracks, and zooming in a little bit to London. And not surprisingly, a lot of the tracks are electrified in London, so that's why this is showing NOx emissions. So there's lots of green there. But at the same time, you can see a few lines showing a slight sort of yellowish orange color, which shows a high emissions because of quite a heavy traffic, I would say, and also the use of more diesel-based trains on those lines as well. And within the online tool, obviously for GIS, you've got the table of attributes, which contains all those powerful data that we have collected so far. Next slide, please. And with the production of this online tool, there were some additional analysis being done. So in the NEI, the emissions are based on grams per kilometer, so they're distance-based. But also what we have is what we call the notch-based emission factors. So notch is a little bit, it's not quite exactly like car gears because they're actually very different, but you can take that notch as like it's related to the power output for the trains. So the lower the notch, the higher emissions there are, is essentially. So we use this notch-based emission factors and apply it at a much more local scale and detail level. So to look at the comparison between using distance-based emission factors and notch-based emission factors and compare the total emissions in 10 selected areas, focusing around AQMAs. And we also did a trial run for dispersion modeling at the selected stations by applying this notch-based emission factors and investigate what's the potential impact on that local air quality if we apply this high level of details emission factors and see how it looks like on the local scale. And as you can see, the contour plots are shown at the top bottom two figures. On the left is the ground floor annual mean NO2 concentration predicted. And then on the right is the one at elevator height, basically around where the roof of the train is. And not surprisingly, you can see hotspots at the busy road junctions on the ground floor level. And then on the right, you can see that there's a spot where the station is or where the platform is. And that actually shows where the trains are idling. Next slide, please. So in terms of the key findings, based on the revised emission factors, the distance-based emission factors, and the analysis we did for the AQMA, we found that at I would say at the sort of the largest urban AQMAs, the percentage contribution from rail emissions account for up to 7% rather than the 2% on a national average basis. Although this percentage is low, but you can see that within AQMA, especially where there are lots of train traffic, actually the contribution is higher than local national average, which is not a surprise. But the percentage arguably is still relatively low. This percentage figure can be high in smaller AQMAs, but at the same time, the absolute emissions, not concentration, the absolute emissions is also lower. And then, relatively speaking, because the total emissions are also lower, so that's why the percentage figures that we found were higher. And moving on to the notch-based emission factors analysis, and then again, not surprisingly, the emissions that we have calculated were actually quite a bit higher than using the distance-based emission factors. One key thing that should be noted is that for the 10 selected areas that we have looked at, they were all centered around key AQMAs with large stations. So at stations, naturally, you will have lots of idling trains or accelerating trains, and then the notch-based emission factors, because of that use, will naturally push up the emissions, and that's what we expect as well. From the dispersion modeling that we have done, and we found that at ground floor receptors, the road traffic is still the biggest contributor around this on a specific case for this specific case, obviously, is about 13 to 51%, comparing with about 3 to 10% from rail. And then on the first to second floor, obviously further away from roads, but closer to rail, the contribution from road is around 11 to 44% and about 5 to 11% from rail. And this finding is similar for PM10 and PM2.5 as well. So the next project is the T1233 Air Quality Targets project that is in progress. And actually, this project literally just kickstarted around last week. The main objective for this project is that we want to set up targets for key locations within rail. As James mentioned before, it needs to be some practical targets, but also ambitious enough, enforceable, and with the ability to monitor progress so that we can drive improvement in air quality for the rail industry. And also one key thing is that right now, although obviously there are standards or objectives being set up by different authorities at different locations, but there is some ambiguity as in what sort of targets actually apply for rail. So in terms of this ongoing project, there are 5 key pieces of work that we are looking at. So first of all, we are trying to look at how air quality currently looks like in the rail industry. And also we want to find out how this sort of usage from passengers and staff, how much time they spend in stations or the various locations, the frequency, duration, etc., etc. And then the second piece of work is we want to look at the relevant standards that currently exist, and also the latest research regarding the link between exposure to poor air quality and the health effects. Then the third work package we want to look at is how air quality would change in the rail sector in the future, taking into account all the known mitigation measures that are planned, like for example, the electrification or the rollout of bi-mode trains or even electric trains. So how would that translate in terms of the benefits in air quality? And the fourth point is actually very important because we want this to be a collaborative project with the industry. We want to know how they think about the methodology that we're going to use. And also very importantly, once we have set up these measures, or these targets, I should say, how much will it cost for them to achieve these targets? And then finally, obviously, what these targets are. And then the last project that I'll go through quite quickly is one of our largest projects right now, which is the air quality monitoring network at the stations. So the reason for this project is that there is currently very limited data showing how air quality is actually like at train stations. And there's only a handful of research, one done by University of Birmingham previously at New Street stations, and also a couple of studies done by RSSB before. And these studies show that air quality in stations can be poor. So as a result of this, there's a need to develop and operate this monitoring network. The key objectives is that we want to gather sufficient baseline information to determine where we are. And then based on this information, we want to prioritize where improvement measures needs to be implemented. And then also with the data, we want to see that, well, with all these mitigation measures in place, how effective they are with regards to all the policies and mitigation measures implemented. And also there's the desire that we want to inform the public how air quality is like at train stations. And on a much longer term, this will be like a trial to establish the most accurate and cost-effective way to measure or monitor air quality in rail stations. Next slide, please. So a little bit about the project. So it's a 3-year project funded by the DFT and delivered by RSSB, and with lots of partnership and cooperation and supported by our friends Network Rail and all the different train operating companies talks as well. It will cover approximately 100 stations across England and Wales. Because of the devolved administration, Scotland is not included right now in the program, but we are actually exploring running a parallel program with them. In terms of the stations, how we choose the stations, actually they are prioritized using the output from the project that I just described, because I've got emission data, which we can identify potential hotspots. And then there are some other factors that we took into account, like for example, enclosed stations, whether there are sidings or depots nearby because of the presence of these, but there may be idling trains present, which drive air quality in the wrong direction. Currently, we are proposing to use 3 types of monitoring equipment: diffusion tubes, the reference monitors used in the URN, and also low-cost sensors. But the low-cost sensors is something that we are looking at to determine how widespread they will be deployed. Next slide, please. And this is how it looks like in terms of the geographical coverage. And this is just professional, but as you can see, it might be a bit small on your screen, but the yellow dots basically illustrate where these represent stations that will be, or provisionally will be covered by this monitoring network. Yep, next. So I'm handing it back to James to talk about some key messages that we want to bring over to all the audience and in the IAQM.
Thank you, Philbert. Yeah, thanks very much. So yeah, just to finish off. So the main challenge that we have really within rail is that because it is very fragmented, that leading a coordinated response is sort of key to make sure we can understand and improve air quality and ensure we have a consistent approach across the network. So examples are, for example, the coordinated monitoring network that Philbert's just talked about, and making sure we have common parameters to measure progress against. So the Air Quality Targets project will develop those. It's important to note that funding for our research projects is from the DFT, so we have to go through a public tender process. I'm sure some of you have already sort of applied and maybe even been successful for some of our projects. And one of the things that we wanted to sort of highlight today is as we really sort of increase our knowledge of air quality in rail, and as we start to see an increasing need for more work in this area, there might be the need to set up some guidance in relation to air quality in rail. And yeah, we'd be interested in exploring this with the IAQM. So yeah, that's it from us at RSSB today. We'll hand over to Azhar Quaiyoom from Network Rail.
Thank you, James.
Okay, sorry.
Sorry, James, I need you to stop sharing. Hi, good afternoon, everyone. My name is Azhar. So I'm a Chartered Engineer, Environment Specialist in Network Rail. I've been working in improving air quality within our main stations, Network Rail, and that's what I'd like to talk to you about today in respect of some of the challenges that we've been facing in respect of air quality more with our in-coal stations, and the work we've been doing in respect of mitigation and improving in our targets and the plan ahead and action plans. Just conscious of time, because I know that we need some time for Q&A, but in respect of why is this so important to Network Rail? Well, there is political pressure, as RSSB highlighted. Even though rail is not a big contributor in respect of emissions, there is some challenges on the local level where we do envisage and have also seen levels of quite high emissions more in our coal stations, and also understanding what the strategic framework is around our regulation and compliance and legislation, which we have done quite a lot of work around the requirements and legislation within stations and depots, which we work to cost regulations, which often there is confusion around the outdoor EU air quality directive and the fact that stations are not liable in terms of compliance to that, but we are liable in terms of regulation, workplace exposure limits within cost regulations. And some of the challenges that we face are the fact that no station is the same. There's so many different dynamics and challenges in tackling air quality within stations, you know, from anything in terms of frequency of trains, types of trains, how long trains idle within platforms, the geometry of the stations themselves. So there's so many different dynamics in tackling this, and there's not one size fits all in respect of solutions. So how have we approached this as Network Rail? Well, we realise, and working in partnership with RSSB and our partners, that we really need to increase our data and within stations, and our bank of information, respective measurements taken and monitoring taken within stations, so we can understand what is our baseline of where our issues lie, and then manage this in terms of creating air quality action plans, collaborate with all our partners within the train operators, freight operators, and all leaseholders within stations, as well as our regulator being the ORR and our partners at the RSSB, and look at innovation, which I'll talk to you about very shortly. And also to mention that very recently, back in the last year, Network Rail issued a new sustainability strategy, and within that strategy, as well as looking at decarbonisation, there is a focus on improving air qualities within Network Rail assets, predominantly obviously our mooring coal stations, and we have set some targets by 2030 for improving by 25%. So again, things are becoming more ambitious in respect of tackling air quality, as well as other environmental issues and impacts that the rail industry can influence and Network Rail can influence. So we come up with a 10-point action plan, which is multifaceted, because we realise that Network Rail can't independently unilaterally improve the situation within stations. It has to be a multifaceted approach with our partners in train operators and freight operators, and people running the rolling stock and manage the emissions in terms of the locals themselves. But we are very keen to improve on standards and looking what we can do and influence within our stations. We're looking at greater governance and monitoring, as I mentioned, working closely with RSSB and increasing our information mass and monitoring. Looking at briefings as well, so working with both the Network Rail staff and train operator staff to understand and create that behaviour change and the importance of air quality. As I mentioned, cost risk assessments, we really are looking to increase this, because first and foremost, we need to assess the situation and the extent of the emissions compared with regulation and standards under the workplace exposure limits, EH40, which is what we were looking to as a guideline. And the fact that these are also being updated, has been an update recently in January. And we know that in August 2018, there was an update in respect of monitoring NOx, and NOx is one of our biggest challenges. So the other things we did learning from Birmingham, which I'll talk to you about shortly as a case study, is improving the communication lines with our train operators by creating air quality focus groups and really increasing our stakeholder engagement with all our partners, including the local authority, because we have to be conscious that some of our stations will and are within clean air zones. Birmingham being a prime example, will introduce a clean air zone within the summer, but trains won't be part of that. And we're very keen on looking at innovation, which I'll talk to you about shortly. I won't go into this in detail, but we've already heard from RSSB in terms of the programmes of monitoring that will be undertaken over the next 3 years. And we are very closely working with RSSB to provide the access and share that information as well to create the action plans that we need to improve the situation. In terms of case study, as James in his very early slides alluded to, you saw the graph there where New Street was quite significant around 2017, 2016 in respect of its emissions. And that was really the trigger that started a lot of this really good work that Network Rail are doing in air quality and improving, because we found that emissions were high. Network Rail is a very challenging station. You know, it spans 250 meters, at least on 12 platforms that are subsurface with a big concrete lid above it, with a fairly short floor to ceiling height compared to a lot of the other stations. And there's a train on average every 37 seconds, at least 40% is diesel rolling stock. So great challenge there. And this was highlighted back by the University of Birmingham. We then engaged with a study with them. And we found lots of interesting things around this. It was the first kind of undertaking a study of its kind at the time, but it helped us engage in respect of what is the actual legal requirements that we need to adhere to within stations and depots. Who will be responsible within Network Rail, because this cuts across station operations, environmental management, health and safety. So many different roles and responsibilities there as well, which we needed to acknowledge and work in respect to the guidance. So what can we do in terms of our ventilation systems in accordance with HSE and HS guidance, such as 187, for example. So that was really a lot of really interesting work that came out of that. And what did we do about that? So when that study was undertaken, 2016, 2017, we amassed a lot of data that was presented to us in various papers. We carried out a significant undertaking at New Street Station to enhance the ventilation. This was previously installed in the old kind of, to the old HSE guidelines 187, where CO2 was seen as a good kind of surrogate for monitoring all the other nasties that come out of diesel emissions, which in fact the university study identified as not the case. So we installed additional NO and NO2 sensors. We closely manage these and control these and integrate into the building management system. And we created a just-in-time state-of-the-art HMI screen within the control room, so we could closely monitor real-time emission levels on each platform and link them to an 8-speed fan system. Before it was only 4 speeds, so it wasn't very well controlled. And now we see the effectiveness of the fans a lot greater than it was previously. And we've seen a great reduction in emissions there as well. And also alongside that, it couldn't be done just with the ventilation system. We work closely with the train operators in reducing train idling. Train idling is the main source of excess emissions, particularly NOx. So we work very closely with the train operators in terms of looking at behaviours, looking at stopping positions, and they did some great work. There was a software upgrade in respect of the class 220s to Pendolinos, etc., and how they can improve the situation by shutting the engines down after 6 to 12 minutes. Avanti have actually improved on this, got this down to 4 minutes. So when the driver removes the key, the engine starts to shut down to an auxiliary level within 4 minutes now. So that was a great improvement as well. And we looked at health checks in terms of all the station staff as well to make sure there's no long-term impacts from exposure of diesel emissions as well. And as I mentioned, working close with our partners in RSSB, DFT, to an extent where the ventilation system was undertaken in 2019, we have seen at least a 30% improvement on average. And these were readings that were taken pre-COVID, because COVID's obviously had an impact in terms of the train frequency through a lot of the stations. So this isn't skewed by that, but you can see the patterns are there because the train frequencies are the same, but the emission levels have reduced quite significantly post the ventilation system upgrade and the enhancement of the system by introducing NOx sensors to trigger the fans reaction. And I mentioned innovation as well. So as Network Rail, we are very keen to seek innovative products and equipment that can help improve air quality within Network Rail stations. So anything in terms of filtration, ionization, chemical processes. We know there's some products out there. We have been approached by some suppliers, but we have backed many Innovate UK bids. So Network Rail and R&D in Network Rail are very keen to improve as much as we can by looking at innovation and looking at what is out there to not just exhaust emissions out of the stations into the ambient atmosphere, but also looking at ways of filtration and ionization chemical processes that can improve the situation, not just within the station, but around the station as well. So we're continually looking at this. We're working with various suppliers. We're waiting on data back from various suppliers who have various products that claim, you know, a lot of good improvements and positive improvements, particularly within NOx and PM. So that's where we're at the moment. I'm conscious I've gone quite quickly through that because I'm sure there'll be quite a lot of Q&A, but thank you very much for participating and this opportunity to present. So thank you to IAQM as well. Thank you.
Thank you very much, Azhar and James and Philbert, for your interesting and informative presentations. I'm going to go straight into questions because we've got quite a lot going through, but thank you very much for that. So first, we've got a question for Philbert. The emissions factors project has highlighted that emissions are greatest in lower notches. Freight trains spend a significant time idling its signals. what work is being done with the freight operating companies to address the emissions from such idling and the locations at which they idle?
Yes, sure. And actually, this question, James might be in a better place to answer, because we are actually looking at anti-idling, which James can give more details.
Yeah, so we do have an initiative which came out of one of the recommendations in the strategic framework, and actually is built on some of the work that Azhar has led in New Street, looking at reducing idling. And the RDG, which stands for the Rail Delivery Group, which is a sort of representative organisation for train operators, are developing some cross-industry guidance on idling. And there are also other technologies, so automatic engine shutdown technologies that can be employed and that are fitted to a lot of freight locomotives, that sometimes need sort of additional levels of training to make sure that they're used appropriately.
Great, thank you. So moving on to the next question. What year are the emissions in the GIS tool based, and is there any aspiration to provide future year projections following anticipated or planned interventions?
Sure. And the emissions, or at least the activity data, were based in 2019, and that's when the project was commenced, and that's the latest a year of data that we've got. And in terms of the future prediction, yes, we are exploring various ways to do a bit of further work based on this project, because it's a very useful, powerful tool, and it's one of the things that we are considering right now. And but we haven't yet made the decision or confirm what exactly should be done to further enhance the project. But it's one of the things that we will look into.
And are you thinking of making the GIS tool available to the public?
I can answer that one. So at the moment, because we've only just finished the project, we're sort of restricting access to rail industry stakeholders. What we could potentially do is make some of the GIS levels available in terms of the rail emissions predictions for future studies. So, for example, we are talking to an academic organisation in terms of how we can input our rail emissions predictions into some other modelling they're doing, enhanced air quality modelling.
Great, thank you both. And are RSSB and Network Rail doing much to investigate the air quality inside trains, whether that be for occupational health and safety and or customer health and well-being?
Yeah, me again. So yeah, we're aware of some studies that have taken place in other countries, in I think Canada and Denmark, and yeah, we have undertaken a project to try and establish air quality levels. The nature of that project has meant we've had to postpone it with the various lockdowns, but we're looking to complete that this year.
Great, thank you, James. One for Azhar now. Can train operators fit diesel particulate matter filters and NOx catalytic converters to their trains?
Yeah, it's a good question. So we've been working closely with some of the train operators, but also the RSSB, so the rolling stock operators that own the trains, and they have tested SECR and filtration equipment. They have had a few challenges. One in particular, Porterbrook, are quite advanced in this, actually, looking at rolling out SECR on some of the rolling stock. What they found, though, was the effectiveness reduced quite significantly during idling, and idling is where you really need to capture the emissions, particularly when they're idling at stations, and that was due to exhaust gas temperatures, which are different within vehicles. So that's a challenge that they've faced, and I think they are quite advanced on this now. We have to catch up, which is due very soon, to see where they are. Last meeting was that they think they've resolved this issue, and they'll be looking to advance this. But apart from that as well, it was worth mentioning that a lot of the RSSB's doing some really exciting stuff on innovation. They're looking at hybrid trains with batteries, so coming in a mile outside of the station on batteries and leaving a mile out before diesel engines kick in. The hydrogen train, which was successfully tested before Christmas on the main line, again, quite exciting as well, but we'll need a lot of infrastructure to support that as well. So there is a lot, apart from the SECR and that question, there's a lot of exciting stuff. We really feel that the hybrid battery technology, if successful, can make a big difference in respect to emissions within stations. but so can some of the other things as well. But that is one that we're really keeping an eye on to make a real significant difference. So yeah, it's a really good question. It's worth mentioning that there's a lot going on in that side, as well as for Network Rail, I focused on filtration equipment because that's what we can influence within stations. I can't obviously talk on behalf of train operators, but we do know when we talk to them that there is these exciting projects going on.
Oh, that's really interesting. Thank you. And when considering air quality inside train stations, have you looked at the difference between closed stations like Paddington and open stations like Reading?
Yeah, as part of the monitoring project I mentioned, there will be a mix of stations, including both enclosed and open stations. And obviously for open stations, it's heavily influenced by external air quality as well. So yeah, from the stations monitoring project, we will gather data from both types of stations as well.
Great, thanks, Philbert. And I guess this could apply to any of you, but how do you see this work linking with decarbonisation of the rail network?
So we do have a decarbonisation work stream within RSSB, and which obviously Network Rail are heavily involved in. And obviously a lot of what you would do in terms of decarbonisation will improve air quality, but is probably going to happen over a much longer time frame. So electrification can't be done overnight, and hydrogen trains, although the trials look quite encouraging, the infrastructure and that kind of thing will take some time to implement. So we recognise the need to look at air quality improvement measures in the short term, but actually some of our findings on air quality may help sort of accelerate the decarbonisation efforts. So yeah, we are making sure the two work streams are sort of in line with each other.
That makes a lot of sense. Thank you. Moving on to another attendee question. Non-exhaust emissions are likely increasing in significance with the electrification of the rail network and newer trains. Are you accounting for these non-exhaust emissions, for example, brake wear, resuspension, in your particulate matter emission factors and modelling?
Not yet. We did a sort of high-level literature review, so recognising that they could be an issue, and they are a big issue in the automotive sector. So we've done just a high-level literature review to understand the need to potentially develop factors for these. But within that, we're also trying to understand the size of the particles and the dispersion. And we are in touch with work streams ongoing in Europe, specifically Germany and France, where they have an increasing focus. They have less diesel trains, but they are looking more on abrasive emissions.
Great, thank you. One for you, I think, Philbert. What type of low-cost sensors are you considering in your monitoring programme?
Yeah, we are assessing the various low-cost sensors available in the market right now, and it's part of our review process. So at the moment, we have not made any decision yet, but from the review process, then later on, comparing with different performance or specification required, then we will make a decision based on that.
Great, thank you. And another one for you. What are the exact emission sources considered in your emissions inventory?
For the mapping tool, the specific calculations or modeling were being done from the exhaust emissions from trains from various different classes, different train types, etc., etc. And then for the emissions from other sources, we took the data from NEI.
Okay, perfect. I'm sorry, I'm going to have to finish it there. There's loads of questions. It was a really interesting presentation, and I hope the discussions can continue on this. So I'd like to thank you all for presenting. It was really great to see your presentations and to see what work is going on in the rail sector in this space. So thank you as well to all those watching. I hope you all found it beneficial and informative. This webinar has been recorded and will be made available on the IAQM website and the IES YouTube channel. I just wanted to highlight the next IAQM webinar, which will be on the 24th of March, where Anil Namdeo will be discussing air quality management in the UK and the factors that are contributing to the failure to meet air quality objectives. Again, this is free to attend, so please do visit the IAQM website to register. I'm also just going to drop a quick link in the chat box. Bear with me 1 second. There you go. And this is for the IAQM's online conference being held next week on the 24th of February. This is DMUG 2021. And if you're a professional engaged in air quality modelling, this conference will provide a platform for knowledge exchange, debate and discussion on topical issues in this area. Thank you once again for all our speakers. Really appreciate you taking the time to do this webinar, and thank you all for watching. Thank you. Goodbye.
Thank you.
Thank you.
Thanks very much.
Thank you.